Testing, testing audio. How was dinner? It was all right. I did not go to the Chick-fil-A. I went to the hotel restaurant and got a steak and French fries. And now I am back to look at this bug where the matches I'm very confused by this because supposedly we move the matches into the constants block. And then why would we match them again? Probably because something bad happens next. Where are let's see where we are. Oh, we didn't set that. Dang it. Oh. First, line 699. Okay, yeah. So this is what's making it a complex looping thing, is we're calling a polymorphic function with a polymorphic argument. So that sort of goes to this harder case. Okay, so we've just done move matches into constants block. This should be a declaration. Right, it's got an expression. It's also got an inferred type. So this is like filled out. It's bound to a type, as it should be. So this appears to be working fine. This could be wrong. Inst wanted. We set that because we want to re-infer it every time. Okay, but we get that out of prop correctly, so okay. We set inst wanted. Or type wanted there. Okay, okay. Next iteration. Oh wait. No. Now next iteration. I don't understand why we are still looping. What is the exit case here? Wait, we're here for once per input. How did we get two matches? We supposedly got matches for T and R. I feel like something super fishy is happening, and I don't mean superficial. Could be superficial if by fiscal you mean fishy. Why did we... Let's just kill these. Okay. So it was this called a quick sort, right? So here, yeah. Now, how is it that we're getting matches for T and R from merely the first argument? And then I bet we're going to get matches for both again. So here we just copy these over. Oh, no, we only got one this time. We got a match for T, which, I mean, I don't get it. Okay, hold on. We are so I is 1, right? Dude, I hate Visual Studio is just such a piece of garbage. I can't believe it. Like, I'm in the middle of trying to work and it just does this. I hate you guys. Okay. What happened to my breakpoint? It's gone. It's like they're trying to be too smart and they end up just ruining everything. Okay. Anyway, so we're going to go back here since our debug was derailed. I is 0, inputs subs or dot data 0. So we have we have a type wanted. It's got some poly matching in it. This type wanted should in fact be just this. So the inst wanted should be an array that points at $t, right? So array element type and then type valued expression. This is really something that maybe could be fixed, abbreviated. Anyway, so it's an identifier. It's going to be the identifier T if we look at it. So that's fine. You're watching the VOD and got interrupted. Well, sorry. Maybe I should have deleted the VOD. Okay, so I'm calling check that types match. And when we get back, we're going to have a T match and an R match. And that's really weird. Actually, let's verify that real fast. Boom. Okay. Oh, wait, maybe not. Now I'm confused. Now there's only one. Wait, maybe I'm misremembering what I saw. Maybe I had my breakpoint in a different place. I think I did. So I think here is where we find the R match. Yes. Okay, so here we have a match for T, a match for R. Okay. Now we move them into the constants block. We did observe that that seemed to work fine. Okay. So now let's see what this type is. This should not be a polymorphic type anymore. It should be an array. Since we had a match for T, it should be an array of something concrete, right? So array element type, no. Okay, this is fishy. I wonder if force infer. So this is why it didn't work, because we didn't do anything. God. Get rid of all these, dude. Okay. So commands to register is just a function or an array. It's an array with a very well-defined type. So we should have a match for T. And I assume that we do. I assume that this part came through. Let's see. Inferred type is, wait, oh, sorry. This is a type definition, right? Okay. Yep. So pointer to a struct code declaration. Why is it a... Oh, because that's the array element. Yes, that's correct. Okay, so this match has the right type in it. The problem is this thing didn't work. So this force infer of inst is maybe not doing what it used to do. Like there might be some code in there. I don't know. Wait, what? Okay, right, I get it. So are we setting the wrong when we, what's our block? Bet it's the wrong block. No. I set the parent, right? Constnats. Okay, that's the right value. Those match. Because one of the things that could be wrong is when we go to re-infer this type instance, we could look up the identifier in the wrong place. Well, I mean, let's just see what T is bound to here. We should be able to see it really quickly. Members, data, 0. It's a declaration. It's bound to a type definition. That's a pointer to something, a pointer to a struct. Yeah, I mean, code declaration. So that's correct. All right. So the declaration inside the constants block. Oh, wait. No. 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 I mean, I guess I just have to step through the infer. So we're just looping through this and we're clearing out some things so that we could recompute them. Okay, and then we go in here. This is like one of the main loops of the compiler right here. Just figuring out what types things are. It's an ident. It's no resolved. Oh, the idents. The identifiers in closing scope pointer. I may point to the wrong place. Not sure exactly how to know. This is an arguments block, but is it? It's the arguments block of the lambda guys. How did this ever work before then? Did force infer do something with ident and closing scopes? So basically, the the enclosing scope is still pointing to the source lambda. Which means that it is, well, it's going to find the polymorph variable in the constants block. And that is not what we want to do. So the question is this the wrong identifier somehow? Or when we copied it, maybe we didn't do the right thing. So I copied the arguments block manually. Remember this? Those of you who were here? Oh, guys, right here. I'm saying the outer scope for this is this. That is, that's a no-no. That's a Janene right there. Thanks, chat, for catching my bug. That only took 17 hours. Oh my God. All right, well, we compiled the game. That's quite amazing. That's a step forward. Like, we can check that in after doing no check-ins and stuff, if it passes the tests. How's it going, everybody? What's going on? What was the highlight of your day everybody? Oh yeah, let's see if the game runs. What was the high point of your day? The high point of my day is probably walking on the beach. Look, it runs. You got an extra $11 fitness band. San Francisco Zoo. Isn't that all of San Francisco at this point? Tried Dear Gooey and you really like it? All right. Watching Queen's Gambit. Building an infinity mirror. Not being in a red state where the riot is. No, the riot's in Washington, D.C. Right? Like, D.C. is very Democrat. Unless there's some other riot that I don't know about. Rendered a rectangle using GL. Well, if that's your high point of your day, like, life can always get better. No, that's a good thing. Wait, there's more in Minnesota? Why are there... What's going on in Minnesota? We tried Snakebird today. Yeah, I hope it's real Snakebird and not Snakebird Primer. Snakebird Primer is not good. Snakebird is pretty good. It's not Steven Sausage Roll good, but it is pretty good. Today was only DC. Am I near Myrtle Beach? I don't know where Myrtle Beach is. Gladcore doesn't include GL Rect. Honestly, nobody uses GL Rect. If that's even a thing. Like, is GL Rect a thing? You know, mostly people would just call GL Vertex for the four corners because then you can very easily rotate it or turn it into whatever polygon you want. Yeah, like GL Rect, is that even... supports efficient specification of rect. No, nobody, that's not efficient. Nobody cares. Like, nothing is optimized for this. Yeah, don't bother. Use GL Vertex. Do I make assets to the game myself? It depends on what you call an asset. Puzzle designs, yes. Graphics, no. Audio, almost none of. Water refill, well, I get it from the faucet, so that depends on what you count. This is pretty good. Did we? Oh, we did. Let's just make sure release build runs, and then we'll check that in. And that still doesn't fix the bug that I had wanted to address yet, but it is a positive step in that direction for sure. For sure. Is it worth learning pre-modern OpenGL? I wouldn't bother. See, I'm hoping this runtime is because we're streaming. I hope I didn't just make it super slow, but I don't think so. It shouldn't be any slower, actually. It should be the same. All right. Great. Great. Oh, do we have no check-ins? Probably. I have a no check-in explaining this somewhere. No, really? Okay. Okay, so that is less messy. You don't think DirectX and OpenGL is modern anymore? No, DirectX is modern. Even DirectX 9 is much more modern than GL, but DirectX 12 is very modern. DirectX has not stopped. Okay. So now we still have a couple weird things. So in the looping case, we still like have a lambda. No, that's it's for arguments. And that does kind of suck, and we are going to have to work on that, but I wonder, I'm just thinking about how to change this looping implementation to like not be specialized. I don't know. Think about it later. Not going to worry about it. Okay. So anyway, we get our array of matches. And now in do polymorph, I guess the thing is to change this. And now this is the part. So I wasn't sure if we would get back to a working program even for that, and we did. So that's great. It's been successful already. You thought Vulkan is more modern? No, that's not correct. Not correct. Okay. So we do some type checking in case it's an intrinsic. Then here we make a lambda, and all this stuff I actually don't want to do. So here we just want to make a polymorph proposal again. So this is all this stuff that we copied from. So we do all this stuff to make the lambda. And then we say apply value bakes. And then we run the modify directives. which doesn't need the polymorphed lambda at all, except for the constants block, which we now will have storage for elsewhere. So this is all fine. There's nothing in principle scary about this at all. In fact, before making the lambda, we could use the progress. Okay, so I'm getting an idea of how to handle this, which is incrementally, right? Because again, this is a very core system. I don't want to like totally destroy everything, but all these major steps down here we can do with the polymorph progress, and then down here at the bottom, well, we could actually do this on the progress, right? And then down here at the bottom, where we start doing all this other lambda stuff, we can actually just make the lambda here. And do all these things, and then we'll return that, and that should plug and play into the game, or into everything, the game and the demos and all that, tests, just correctly, because we are still returning the same thing that we used to return. And then the next step after that would be to factor this into a separate function. Maybe we would do that. It would be like make actual lambda from source lambda and proposal. And then that would be a good time to check in again, because then the next step is to change what this function even returns. That sounds like a good plan to me. Okay, here's what we even can do. This apply value bakes probably gets called from the bake function as well. Wait, no, this is the only place. So we're free to change this to take a proposal. Because it's C++, we have to do this a million times. Okay. We go through all the bakes. We get the source declaration. We get the argument. We look it up. Except, wait, we don't need to do this. This is removing it from the arguments block. Okay. what am I trying to say here? Will not have their bakes be the actual arguments, but rather polymorph matches. Okay, this is extra. See, we do all this stuff to make this polymorph proposal, and then we throw it away, and we're going to make another one and fill it here. Oh, that's only in the looping case. Maybe we don't care about that. Clean up the barf. Clean up the barf. Okay. Yeah. So I'm still just straightforwardly translating all the things. Okay. Great. In order to do that, we need to say prop. It's an auto prop airplane. Oh no, sorry. So we want to make a lambda from proposal here. All this stuff. We're going to deal with later. Putting all this down here, like I said. Although honestly, we could make even less of a mess than this by not moving this yet. Because we could have all this stuff take wait, what? Where are we? We're in okay, so we just say progress arrow lambda equals lambda. Okay, yeah, so that's what this does down here as well. So we're just moving all that down. That's going to be a big mess. And then up here, there is no progress lambda. we want to say make prop is make poly proposal. Okay. But the stuff down here where's the part where we put the bakes? This part. Okay. Okay, so here we're not going to do this. We're going to go that's our proposal there. And that means this doesn't do anything. We apply modified directives to that constants block. And then we do find matching polymorph for how many calls is there? Just two, one for structs, one for procedures. Great. So we're going to change this also to take a proposal. Oh, okay. Otherwise, we'll deal with this stuff. Yeah. All this is going to get factored out. So that's the returns block. That all still, well, no, this all can happen. All right. And actually, this doesn't need to be interp. That's going to be a method on polymorph. I usually don't do this much in one go. So all that goes in there. So how did we make the lambda? Should we just call make lambda? Okay. Probably a bunch of stuff in there that needs to change. No, well, certainly we're not using the proposal here. Okay, hold on. Do you copy the flags, foreign function name, polymorph depth? That's great. Okay, here we don't want to copy from source lambda. We want to copy from the proposal. From prop, not source lambda, because auto bakes may have removed arguments and so forth. Okay, so okay, put the arguments into the basket or it gets the hose again. We don't set this. Just return lambda no matter what. We don't care. If we reported an error, that's fine. We don't have to want the caller to have to worry about null. So if anything's unbound, we reject it. Okay. I messed up a million things. So I never changed the function. We were taking a procedure argument. Wait, did I? I don't know. Let's just look at what we broke empirically. Source lambda. Right, we need auto source lambda is prop source lambda. Great. Did I set that? Yes, okay. We don't have a site. Bro. Okay, fine. Fine, C++. You win at making me hate you. Okay. 316. Grr! Bro, why did I do this to myself? C++. How's it going, everybody? Polymorph depth. we just get that off? Oh, really? Okay, that's fine. Okay. Well, we're getting toward fewer errors. Void function returning a value. Obviously, this is not void. And obviously, we have to change twice because it's still C++. It hasn't miraculously stopped being C++ in the last 10 minutes. Silent check. So we could pass a silent check parameter into here, but I actually think this is better done from the caller. That's fine. Although, actually, we should do this on the prop, because the lambda's constants block is just going to come from the props constant block. Okay, there we go. Okay. Bro. Okay, we don't have to worry about the lambda going hot or not going hot if it doesn't even exist. ProRes, this compiler is in QuickTime ProRes, and that's why it doesn't work. Okay. This is what I was saying that we never changed. Oh, this is easy. Easy peasy, dude. Well. Whoops. Except I did it wrong. It was easy and I threw. All right. Also, don't need to worry about the lambda not going hot. Yay! Why aren't my error messages colored? Because Visual Studio is awful. And they do all sorts of weird interactive things in this window that are really slow and laggy to try to tell you about errors before you compile, but it's not really right about that a lot of the time. So it ends up being stupid noise that you have to ignore anyway. And then they never even did basic syntax highlighting down here. It's embarrassing. It's Microsoft, dude. Okay, this is almost guaranteed not to run. Nope. That's going to be an entertaining error to debug, except that hopefully we'll get an assertion instead. Oh. Okay. Okay. We ended up with something that was polymorphic when we didn't want it to be. What is the cause of that? It could be many things. Could be many things. Could be many things. Woof. We don't need so this whole thing doesn't need to happen anymore. We were doing this to make it not go hot and then going hot later. Oh wait, we never, oh wait. Well, that's not going to change anything. Okay. So the question is, why? Let's just run it and we'll hit the assertion. And so this lambda is this. So when we make lambda from proposal, I hope I checked in before doing all this. I feel like I did, but I don't remember it. All right, so we do a bunch of things. Okay, no, we don't actually want this. This is wrong. This is wrong. That's why it's polymorphic. We want to get it from the prop. See, the reason this was fine is because we copied it with all these polymorph variables in the constants block, and then we modified it, but now we modify the prop, so yeah. This is fine. And we copy those from prop. Yeah. Okay. Well, that was better. It doesn't like... I guess the copier has a safety where it says if you ever recurse... Sorry, 346. Copy constants block. Somehow we're recursing down. I don't get it. Let's just see. Okay. Yeah, we're just saying, look. Oh. Oh, no. We're just saying a lambda's constants block had better be parented to something besides a constants block, otherwise that's just an error. I put this in years ago because I made a mistake just like that with parenting things incorrectly, and now I have made the same mistake or a similar mistake. That is when an assert really saves you some effort, because that could have been wrong for a while and I might not even notice. Okay, so the problem there is just, it's actually fine. It just doesn't like the order in which I did these things. Like, I think if I do this up here, no, didn't matter. I guess it's changing. Okay. I was hoping it was the first time, because then we could just stop here, but nope, totally not the first time. All right. So we're going to say come on. Oh, look how long that took. Okay. Okay, that is a data declarations. I bet one of these functions just changes it for some reason. I bet we check if it's a, I don't know. I bet there's a hard-coded weird thing. B8, B8, 1, 2, D5, B8, B8. No. Oh, because this is, oh, right. Okay, guys. This isn't that lambda. This is a new lambda that's in one of the arguments, which is why we didn't hit this on the first time, because, you know, most polymorphisms aren't these complex cases where you pass in another lambda as an argument. What's going on here is we're not pushing the proper block. You know, there's this sort of like push block thing that you do, which I assumed copy block without setting important things. Like, yeah, it does do a push. Wait. How are we getting a lambda? It's actually legal to have a lambda in a constants block. So that assertion is technically wrong. Let's just make sure we're not doing something wacky here. Copying a declaration. Let's just see where this is. Is this in sort? It is, isn't it? Hash table. Okay. Interesting. So what declaration are we having a cow about? Autopoly. Blah, I should put the name in there, dude, for debugging purposes. I can't tell which argument it is, except I can by going here. Sorry, by going here and seeing what I is. 2. What? What? Okay, hold on. Right, we're at... So the reason why it's 4 I don't know why it's 4 things. It should be 2. There's this auto, this is an auto poly here. So there should be 2, oh wait, that's a table though. Oh yeah, no. 1, 2, 3, 4. And look, these are procedures. So that assertion is wrong. It is legal to have a lambda whose outer no. Well, I'm trying to figure out why this didn't trip before. It is legal, but previously these would have been parented to the arguments block and not the constants block. I'm not sure why just moving this code around changed that. It's It's actually technically not correct to have them parented to the constants block. So there's that. I'm just not sure why that changed. The reason why it's not correct is like, well, I mean, it's different. This is like, this is a struct anyway. Well, except these are autopoly, yeah. How's it going, everybody? All right. It is very quiet because nobody cares about anything in programming. Nobody cares. Right. So the thing is, even though these things live in the constants block, their identifiers need to have an enclosing scope sent to the arguments block. And about other things like declaration enclosing scopes, maybe. Like, I don't know, man. It starts to get dicey. So I feel like I changed this part in my chopping stuff around. Oh wait, no, that's not the call that we're talking about. We're talking about... Oh, you know... Yeah. Okay. The reason this was okay before and not okay now is because before we copied the constants block and it was not filled out, it just had variables in it. Remember, because remember I mashed these two things together. This used to be an unfilled out constants block, and then we would do stuff to fill it out, and then etc. Now it's filled out. So I don't know why we're doing any of this stuff here for this case. Okay. Wait, not that one. I just want more control over it, so I'm just going to do all the same stuff. And actually, all this can go out here so that Okay. Okay. I mean, that literally might be it. Oh, except bleh. The inferred types are not going to be set on this, and the constants block does not get inferred. We could just... Is there a reason we can't just use the prop directly? Is that a thing? Is there a reason? I don't think so. I was thinking about this earlier tonight, that we could just do this. It's faster anyway. Ta-da! Does it blend? Does it blend, everybody? Do I want to start a language flame war? Well, I mean, I'm sure such a thing has never been tried. So, maybe. Well, because it's going on 11 p.m. This might just be another short stream. This is very good progress. Now, I'm basically one factor away from solving this bug. So the whole deal is, we do all the polymorph work with this poly proposal thing that we made tonight, instead of with the lambda. And we don't make the lambda now until the very end here, when we do all this stuff. It's a lot of stuff, but you know, this make lambda from proposal. So we do all this. Let me go back to the top of this. This is do polymorph. We do all these steps without the lambda. And then we make the lambda down here and return it. So the next step, in fact, we could actually even move this up. The next step is to not actually do this yet. The next step is to have overloads to return the prop from here. And overloads just use the prop, which hopefully isn't that hard. Oh, well, okay. The problem is overloads. You know, sometimes we'll have a lambda, and sometimes, or sometimes, you know, they'll just have a regular constant function, and sometimes they'll have a polymorphic function, right? So often they will have a lambda, but now they will not always have a lambda, and that's going to be a little bit of a pain, honestly. But anyway, That's the next step. And then once that is done, that'll fix this bug. And then, so with overloads, you use the poly prop until you figure out in the end which exact overload you want. And then in that case, then you call this make lambda from proposal at that time, right? And then the other places that call this, like bake and stuff, can just call this routine and then call this right afterward. So, in fact, the first change, if we're feeling spicy, if I'm not feeling too tired, the first change could be just changing the return value from here and just putting this after the calling site in all cases, right? Because then it'll actually be like ready to go. You heard C# is pretty cool. Yeah. Do you honestly need content though? What is happening? Well, okay. The rules are, I start with a PM pistol with 1 mag. Clear stash on every death. Only found in raid money. No use of shops, and we have to kill all 5 bosses. That's the rules. That's what's happening. I'm not sure how well we're doing though, honestly. It's hard to tell sometimes. Dude, flea market ruins the game. I don't understand why they ruin the game like that. It's so much better. I mean, the challenge that people are doing is obviously way too insane to be the regular game. But like, it's actually a lot more interesting in some ways. Even forgetting the being underpowered thing, but the fact that like you actually care what all these little pieces are and you're trying to put them together into weapons that function and stuff, like that is way more interesting than regular looting in Tarkov. It's so much better. I don't understand why they wreck their game. It's the most Microsoft thing ever to have a virtual machine that only works on Windows. Don't they have like mono whatever for Linux? And what is Unity? Did Unity make their own VM? Like what do they, how does Unity run on PlayStation? Oh, I know the answer to this. They transpile to C. That's what they do. It made your head hurt how into OOP he was. Well, I mean, see, the thing about OOP is, you know, you go hear about it and somebody lays out for you how magical OOP is and how it solves all these problems. And it sounds good, right? Like, here's a whole system of like the way that you do things and it's all right. And it actually takes a lot of experience to realize that that all sucks. It wasn't clear to me for a long time. I just knew that I, you know, instinctually didn't do it very heavily, but it took a really long time for me to be like, no, wait, this is garbage. And so when you're young and that's just what you're taught, how are you going to know better? It sounds good. What problems? You've never heard concrete scenarios outlined. The claims are that OOP makes code a lot more modular, right? And a lot more encapsulated, and it allows you to extend existing functionality without polluting the existing functionality. You know, just go take an OOP class if you want to know. Okay, so yep, that was a release build of the game. All those things I listed can be done better without OOP. Oh, I agree that they can be done better without OOP, but I'm just saying these are the things that people say. And it sounds good when you're new. Right? You know, just like, again, I went to Berkeley and, you know, there they gave us the functional programming Kool-Aid. And I was all like, oh yeah, functional programming is obviously better. Because, like, you believe what they tell you. Until you don't. Which day may never come. Okay. So we're going to check this in. And then we're going to do the final step for tonight. Oh. I guess that's fine. All right. Next, we are gonna not do this. Okay, first of all, we're going to put that there so that we don't have to do that from everywhere. And then this is going to be a poly proposal. It's just a proposal, guys. We're not too serious. Okay, that's just a proposal. And now we're going to return progress prop. Okay. Now, anyone who calls this is now going to be very unhappy, which there aren't that many calling sites, but there are a couple. See? This is the goodness of a strongly typed programming language. Oh, wait. We have another. Oh, because I said return. Oh, my God, guys. It's the fatal flaw. It's actually not fatal. But. Okay. It's not as easy as I was even saying. Because here's the thing. We don't always want to return a polymorph proposal, I guess. Because sometimes you know, like if we've already generated a polymorph, then we just want to return that function. We don't want to have to do all this monkey business, right? About whatever. It's questionable whether we want to keep it that way. So we want to return a lambda sometimes. Or we could always return a proposal. But that forces us to always make a proposal, which we'd rather not do. I mean, we do right no matter what. Okay, so here's the thing. Right now, when you polymorph a function 27 times throughout your program with the same input arguments, we actually make the proposal and do the solve every time. But eventually, I want to move it so that like it caches the output function based on your input arguments, right? So if you give it the same argument types, right? If you call array add with a certain type of array and a certain argument type, then that is going to be the same every time, right? So we just like look those up in a hash table and don't and skip the whole polymorph process. That's like a little bit of an acceleration situation. So okay, hold on. So what I'm saying is this wants to be just an expression or now I might be unhappy dealing with that later, but this first step is not really going to be more complicated, I guess. So slightly. Okay. Anyway, so when we call do polymorph, okay. This is bake, right? No, this is make. Oh God, guys, we're even lol. Right, we're one step of recursion up from where I thought we were. I thought if I stepped out by one, we would be at the overloading situation. But we ain't. That's fine though. Because all we want to do here is say if result is asked polymorph proposal, poly proposal, right? If it's that, otherwise assert it's lambda. All right, so here make lambda from proposal result polymorph depth site. Great, and then result is new lambda. Okay, so that's what we do there. Is that the only call? Maybe it is. Make lambda from, did I forget the, I was thinking of the cast. Did I not type it? I didn't type it. That's when you know you're starting to get sleepy, because I thought it. It's like Clint Eastwood. You must think in Russian. That's what I should have busted out for my talk that I gave in Russia, man. Oh. Let's do this. You must think in Russian. Do we support function overloading? Yes. Does that mean the symbols are mangled too? No. I mean, that's an implementation detail. Because your operating system's linker is shitty, then yes, it means things are mangled. But the programming language doesn't mangle things for its own purposes. That's just because your linker sucks. I must have, hopefully it was a dumb mistake. Oh, actually, we can return null sometimes, right? But hopefully in those cases, we always reported an error. Let's see. No, debug. Oh, let's just run it here. Let's just run it here. Debug break. We debug break. We just a little debug break. Oh, why are we inserting? Okay, I confused. I confused. How did we get a poly proposals? This is exactly. Oh, I was only searching in that one file for calls to do polymorph, but of course it's in another file. There's 3 of them. Okay. Here's what we're going to do. We're going to shrink this up to progress result equals ensure any proposal is converted to no, they're just going to leave it with this. Okay. So this is just going to say, look, it takes a village, first of all, but it also takes arguments of one of these 2 types. Screw it. Okay. So now this thing we can call from typer. All right. Oh, we need more parameters. We needed this polymorph depth and site. Because we didn't have those. Okay. We obviously didn't have those variables. What am I thinking? All right. Now I forgot to make the call. Use those. Oops. Oops. Polyexpert. So we're just moving this out. Okay. Cannot convert. Oh my God. Why do I keep doing this to myself? Okay. What was this? Yep, like I said, I forgot to change the call. Okay, now we run. Now we run. How do we represent types in code? Isn't an int? No, types are a quite complex tree data structure. You can't, I mean, you can't pack enough data into an integer to represent an arbitrary type. You need more than 64 bits to tell what it is. Unless you know some magic that I don't know. I mean, technically speaking, you need a potentially infinite amount of information. Really? Really, we returned null. That's not good. We return null without yielding and without erroring. TCC did types as an int and regretted it. I mean, what? How do you possibly do that? I mean, if you mean the int is an index to a table, that has a more thorough definition of your type, then that's fine. But that's not how you're representing the type. That's just then an index to the type table, right? So maybe I misunderstood the question. Yeah. So this is not good. Okay. I messed something up. Okay, first stop, second stop, third stop, fourth, fifth. Oh, what a butt pain, dude. Eighth stop, 9, 10. Come on, guys. Wait, did this? So this is one of these things that is wasting a lot of CPU that we should fix later. Compiler will get a lot faster when we fix these. So we're waiting on this lambda. I'm not sure why. Not sure why. Oh, because we're waiting for modify directives. Okay. So I'm just going to set the next statement here and hope that what? Squeeze me? Okay. So in that case, we literally must have just added it, right? Which was that thing. Although, wait, what? Dude, I totally don't understand this. Hold on, we're going to restart. Because we're ending up in some state where oh wait, we're at finish. Then why did we do this? Find matching. What? Why did we do this? Right? Set next statement. Go in. Progress. Set to finish. Dude, I'm so confused. Okay, whatever. We check the constants block. Progress arrow prop. Not null. Okay. All right, 705 of string. Min with 2 arguments. That is pretty straightforward. Do we have a modify? Yes. Wait, no. There must be some min in scope that has a frac and modify on it. Okay. What? Oh, source lambda. Line 148 of basic. Really? Oh no, that modify directive weight. It was a different thing that I was confused about. So this is pretty straightforward. How did I mess up that, guys? It's so simple. Well, I mean, I'll just go look at okay, it's maybe this one. I guess we want to assert that an error has been reported there. Okay, this check. Okay, no, we return null if we fail, guys. Clearly. Why? See, that's how you know I'm sleepy. We can fail. So, believe me, we can fail. If you want to succeed in the game industry, fail. If at first you don't succeed, fail and fail again. I kind of want to play that song, except we played that on stream once. Okay. So this just has to take null. Yeah, no, clearly, guys. Clearly. All right. Okay. You're thinking that, yeah, table. Yeah, I mean, you could definitely represent types as an index into a table. If you do that, I would recommend that you not have them be, like, even if they're an integer in actual fact, just have it be a strongly typed integer of some kind. Don't just have it be like int everywhere. That'll make you sad. Even if you have to pretend it's like an enum or something. Okay, that's a new thing that I added, which may not be true. Yeah, we didn't. Oh, because this also can fail with silent check, right? Okay. That was an incorrect thing that I added. Did I add that one new too? Yes, because remember, I just said it's allowed to be null. That was the one, remember I used to have assert result not null there. Hey, hey, does it blend? DMCA, yeah, we'd get totally DMCA'd if we played that song. After what happened to you when you said LLVM could be faster in a programming form, you respect all these guys so much more. What happened? Did people just like flame on you for not respecting LLVM or what? Or like give you all the excuses for why it's slow? Obviously it has to be slow. It does optimization. Obviously it has to be slow. It targets so many platforms. Obviously it has to be slow because your butt. You were murdered by a horde of people after saying LLVM was slow. Like, look, they admitted, like, didn't they just have an entire update where half the point was to make it go a little bit faster again because they just kept getting slower? Like, that was in the past few months. So, like, there's no debate that it's slow. They flamed on me and called me in KC bums. Well, that's fine. I will not hire any of those people. Let's build a release build. I have been bouncing between hotels for weeks like a bum. That is true. They noticed only release mode got slower by 10% every release. Yeah, but debug mode is really slow. Even if it doesn't get slower every release, which I'm not tracking, it's really slow. And it's not optimizing, so what's the excuse? The thing you have to realize about that, all internet communities like that are toxic, all right? Because they consist of people, it's like a sports team, all right? They consist of people who identify with LLVM, and anything you say that is critical of LLVM in any way is saying shit about their sports team, all right? Now, never mind that that's extremely anti-engineering of a mindset and that it guarantees that those people will be bad engineers. That's just how internet communities are. And it's why it's so difficult to find quality, you know, in the internet. Anyway. Great. Okay, so we're in a good place for next time. It's like people, human beings generally speaking, and this isn't even just about technical things, it's about everything. Human beings pretend to be interested in something or doing something seriously when really they're not doing that thing for that thing's sake. They're doing that thing kind of largely for their own ego's sake and then only incidentally for that other thing, right? That's just how human beings exist. It's how they deal with being in the world, all right? And so when you have a big forum full of people who have banded together because they like LLVM or like Vegeta in Dragon Ball or whatever, that's what's going on. Is it's people who are trying to convince themselves they exist and trying to scrabble for the best existence that they can get. It's not about doing the best engineering, because if it were, or about having the best super cyan powers, or however you say that, right? Because if it were, people wouldn't be annoyed if you said LLVM was slow. They'd say, yes, it takes this many seconds to compile this many lines. Yes, obviously it would be better if that number was lower. Like, how debatable is that? If it takes a non-negligible amount of time to compile a large program, obviously it is better if that time is lower, all other things being equal. That's an undisputable statement, right? But people will dispute it because you're threatening to make them look into the abyss in some small way. So like you're actually playing with something a little bit dangerous there. Got told by some guy that you didn't know anything LLVM when the same dude didn't know memory allocations interfere with performance. Yeah, I mean, like, dude. Yeah, don't expect. Okay, here's the thing. Since you're 19, right? This is the very important thing to learn. Okay, so first, look at how that community is reacting. It is nothing specific to LLVM, right? Like programming language communities get like that. All sorts of places get like that. I don't know what I'm going to do. I'm going to try to do something in like the code of conduct to be like, don't act that way. I don't know how we're going to phrase it, but so internalize that. Like, look at what that looks like, because now that you see it very clearly, you can make sure that you don't do that, right? And if you're ever in a place and you look around and everybody in the community is acting like that, maybe it's time to make a fresher, smaller community that doesn't have all those people in it, right? A higher quality tranche inside that community. But then also, that's a good sign of what not to do, which is useful, but then just realize that helps clarify what to do, right? What do we want to do? Just be a really good engineer, right? When part of being an engineer is looking for the best design, technical design, right? And as you know, that means optimizing these various parameters, like, for example, performance. Performance is not the only thing that's important, right? It is sometimes worth trading off performance for other things. But, you need to make sure that that's a very justified trade-off if you're being a good engineer. So you can just use this as a clarifying moment. Just look at that, see what you see, and remember it. And use it to guide yourself in the future. And all of that is regardless of whether I'm correct or incorrect about LLVM being slow, for example, right? Like, regardless of whether you believe me, there are reasonable ways to respond to an engineering criticism, and there are unreasonable ways. And on the internet, what you almost always see is unreasonable ways of responding. Because because it would take effort. You would have to have a tremendous amount of understanding even to respond correctly to somebody saying like something like what you were saying. And most people don't have that. Most people hanging out in these communities don't have that. Only like really core people who are super working on it have that. So, yeah. Have I seen Koyaanisqatsi? Yeah, I saw it a long time ago. I've seen all three of those. I think I saw them in like a one-day marathon, which is kind of a lot, honestly. I mean, they're like 2 hours a piece, right, or something, and there were intermissions in between. So it was like, yeah, it must have been 8 hours, right? Some guy said cache is not the bottleneck and I/O is. Can't they both be bottlenecks? They said GTA 5 was bottlenecked by I/O and so is Chrome. Okay, here's the thing. There are different levels of things to be bottlenecked by. So whoever said GTA is bottlenecked by I/O is, first of all, clueless, right? Because there are different scenarios, okay? The loading speed of GTA may be bottlenecked by I/O. The rate at which you could travel across the world may be bottlenecked by I/O. And it depends on what I/O you mean. Like if we're talking about I/O from disk or hard drive or something, right? Frame to frame of just you standing in the world and like trying to dodge some police or whatever is not bottlenecked by I/O, unless maybe you're talking about like bus traffic to the GPU. And if that is the case, you only got to that being the bottleneck through astounding optimization of getting rid of cache problems. So like, okay, first of all, if this dude doesn't work in games, he doesn't know what he's talking about. Like this sounds like some guy who like saw one, what's the Eurogamer thing? He saw like one of those technical rundowns that they do and thinks he knows things. But like, okay, if you are bottlenecked on disk I/O, that is very, very bad, right? And you have to fix that problem before cache is your biggest problem. But that just means you gave yourself an even worse problem. That's like not good, right? And then here's this other fallacy. Like everyone says, oh, we're bottlenecked on this thing, so other things don't need to be fast. Yes, they do. Like the reason the web sucks so bad is web programmers, every time I talk to web programmers, they say, oh, well, everything responds in 100 milliseconds, so it's fine. And I'm like, no, dude, latency's add. Like, they just don't get it, right? Latency's add. So if you have cache problems and I/O problems, those add. Like, I don't know, man. It's like, look, if any of this was actually reasonable, software wouldn't be complete dog shit. Like, it actually is. Like, we have amazing, amazing computers and software runs like dog shit. So anyone giving you excuses for software running like dog shit is not somebody you should learn from. They don't really know. That's all I'm going to say. Like, Digital Foundry, yes. It's like some guy saw one Digital Foundry article and thinks he knows everything about video games, right? No, no, no. I've been doing video games for 38 years, much of that or some of that non-professionally, but I still don't remotely know a small part of everything there is to know about video games. There is so much to know. It's incredible. So like anyone who hasn't been doing this hardcore for their whole life has no idea. Do not listen to them about anything about games. They have no idea. Samsara is better quality. I like Samsara as well. They don't think stuff runs slow. Well, that's okay. I mean, that's the thing, right? If they don't think stuff runs slow, there's not much you can do. There's not much you can do. Now, I will point out there's a contradiction. They can't say, oh, it's fine that it runs at this speed because there's a bottleneck on X. And then also, things don't run slow. But yeah, this is what you guys are saying is something that I try to raise awareness of whenever I can, is that programmers do not know how fast their computers are. They literally have no idea how much work their computer can do in 1 second, right? Or in 1/60th of a second. They have no idea. The amount of work your computer can do in a 60th of a second is very, very large. Just run the numbers, man, on like a modern CPU. How many cores does it have, right? How many instructions per clock does it have? How many clocks happen in a 60th of a second? It's a large number. You know, 1/60th of like 4 billion is still a big number. Times the number of cores, times the number of instructions per clock. It's a big number, guys. So you have to take your 4 billion divided by 60, and then you have to multiply that by like, I don't know, 4, which is instructions per clock, and then times the number of cores. Could actually do the multiply before the divide. So if you say it's like a 6-core machine, 8-core, let's say 8-core, 4 instructions per clock, that's 32. That's about half of 60. So you have, if it's 4, do things run at 4 gigahertz still? I don't even know. If it's 4 gigahertz divided by 2, that's how many things per clock. You can do 2 giga operations in a 60th of a second. It's insane, dude. I mean, that's of course peak performance that you'll never reach, but your desktop is way faster and has way lower latencies than the supercomputer cluster you used to work on. It was number 37 at the time. Yeah, dude. Desktops today are insane. They are so fast. They are so fast. All right. I think I did check in. Yeah, I believe I did. I seem to remember checking in. So this has been pretty successful. And the next step is going to be well, this is not really a thing worth worrying about. The next step is going to be, well, this part here. Instead of ensuring it's converted to lambda, we want to make this be the proposal or the lambda. And then anyone who calls this, does this make polymorph with called procedure? Yeah. I think that's only got one caller. Oh, it's got two. Oh, but one of them is just the error report. And we don't actually need to care about the return value. Wait, that's, no? What? Oh, no, no, no. Okay, that's the first one. What's this? Yeah, this is the error report. They're in opposite orders in the file of how expected. Because I moved this the other day. They used to be in the opposite order. So this one, we don't even care about we don't even look at the return value. So it's literally just bubbling up the return value to here. Oh wait, poly result. We look at it here. Yeah. So instead of result, I can name it something very explanatory like proposal or lambda. And then anyone who uses it needs to think about that. Do you wish there was a saner way to program the web? Well, people have been saying maybe WebAssembly will make things a little bit better for like 5 years. I don't know how much longer you want to wait for that. Do I actually use Control F navigation or arrow keys? What, in Emacs? I use N, P, A, and E. Okay, let's see if we can host someone. In the science and technology zone. Feed the pond. Oh boy. Sea of Clouds 2. Is that good? What language is that? I can't tell. It's probably Unity or something, right? Take us to Bob Ross. Bob Ross is on. Well, I don't think Bob Ross is really on. You can go virtual assistant. All All right, you know what? We don't have to raid. All right, thanks everybody for coming by. And